Hello everyone, I am Tanushree. In this video we are going to discuss stack and stack operations. The agenda for today's video is introduction, stack operations, implementation of stack, applications of stack and conclusion. So the first part is introduction. So basically what is stack? Stack is a linear list of elements in which an element may be inserted or deleted at only one end, that is called as the top of the stack. Stack is a data structure which works on the principle of last in first one, that is LIFO. The last element inserted will be the first element to be deleted. Next is stack operations. There are mainly four operations in stack. First is push operation, pop operation, display operation, overflow and underflow. And the first operation is push operation. The push operation involves adding an element to the top of the stack. It is a fundamental operation in a stack allowing for the insertion of new data into the stack. Next is pop operation. The pop operation involves removing the top element from the stack. It is a crucial operation in a stack, allowing retrieval and removal of the most recently added elements. And the third operation is display operation. The display operation involves presenting the elements of the stack without modifying its structure. It allows users or developers to view the contents of the stack without affecting its state. And the last operation is overflow and underflow. Overflow. It occurs when attempting to push an element onto a full stack. And underflow. It occurs when attempting to pop an element from an empty stack. And the next topic is implementation of stack. The first implementation is create. The create stack function can be implemented as a one-dimensional array, that is define size 5, int s of size, int top equals -1. Here size is a symbolic constant, specifies the maximum number of elements that can be inserted into the stack. And s of size is an array to hold the element of the stack. So the next is useful. Checks for overflow. In order to perform a push operation, we need to check whether the stack is completely filled with elements or not. That is, if top equals size -1, open the braces, printf, open braces, double quotes, stack full, overflow, close the quotes and close the bracket, and return and close the bracket. So here top represents the index of the top element in the stack and size represents the maximum size or capacity of the stack. The if condition checks whether the top index is equal to size -1. In a zero-based index system, if top is equal to size -1, it means that the stack is full and attempting to push another element would result in an overflow. If the condition is true, the program prints stack full overflow using printf and then immediately returns from the function or program, indicating that the push operation. So next is push. Push is used to insert an element into the stack. First, check whether sufficient space is available in the stack. If available, then increments the value of top by 1 and then insert the item into stack, that is void push. Open the brace, int items, if top equals size -1, printf stack overflow, return, printf enter an item, scanf %d ampersand item, s of ++ top equals items and close the floor braces. Here void push named push and returns nothing, and int item declares an integer variable item to store the value to be pushed onto the stack. And if condition checks if the stack is full. If true, it prints stack overflow and returns from the function indicating that the push operator cannot be performed. And the printf prompts the user to enter a value to be pushed onto the stack, and scanf reads an integer value from the user and store it in the variable item, and s of plus plus top equals item increments the top index and assigns the value of items to the corresponding position in the stack array S. It assumes that S is the array representing the stack. Next implementation is empty. Before we delete an item from the stack, we must need to check whether there is any element in the stack. That is, if top equals -1, print stack is empty under flow, return and close the braces. Here top of -1 indicates that the stack is empty. And here if condition checks if the top index is equal to -1. Inside the conditional block, if the condition is true, it prints stack is empty under flow, indicating that a pop operation and cannot be performed on an empty stack. And return statement exits the function or program session as attempting to perform a pop operation on an empty stack is not allowed. In many stack implementation, the top index being -1 signifies that the stack contains no elements. This prevents underflow error when attempting to pop elements from an empty stack. And the next is pop. To delete an item from the stack, pop is used. Void pop. If top equals -1, print stack underflow, return print delete item %d s of top. Void pop. This function is named as pop and returns nothing. If top equals -1, checks if the top index is equal to -1, indicating an empty stack. If true, it prints stack underflow and returns from the functions, indicating that the pop operation cannot be performed on an empty stack. Inside the conditional block, a print delete item, a %d s of top. If the stack is not empty, it prints the value at the top of the stack, indicating that item been removed or popped from the stack. And the last implementation is display. Display is used to print the contents of the stack. Void display, open the curly braces, int I, if top equals -1, and again open the curly braces, printf stack is empty underflow, return, again close the curly braces, printf contents of the stack are, for here I am using for loop, for I equals top, I less than or equals to 0, I minus, printf %d s of I, again close the curly braces. Here void display is a function named display and returns nothing. If top equals -1, checks if the top index is equal to -1, indicating an empty stack. If top equals -1, checks if the top index is equal to -1, indicating an empty stack. If true, it prints stack is empty underflow and returns from the function, indicating that there are no elements to display. Inside the conditional block, that is printf, contents of the stack are, if the stack is if inside the conditional block, that is printf, contents of the stack are, if the stack is not empty, it prints a header indicating that it will be display the stack's contents. Here I am using for loop, that is for equals top I less than or equals to 0, I minus minus, and I am also using printf percentage d s of I. This loops through the stack from top to bottom, printing each element on a new line. So this is about implementation of stacks, and the next is applications of stack. Stack is used in various applications, and I am listing only few applications, that is used in function calls. Stacks are used in conversion of expression. Stacks are used in evaluation of expressions, and finally it is used in recursion. This is about the applications of stack. And the next is conclusion. Stacks are fundamental in programming, offering in first out structure from push and pop operation to handling overflow or underflow. Understanding stacks is crucial. Their particular application ranging from function call to expression evaluation makes stack indispensable in various programming scenarios. Remember, a solid grasp of stack enhance algorithmic efficiency and problem solving. So thank you for exploring the world of stacks with me, and happy coding. So thank you for watching my video.